Welcome to the module on flexible payments. Today we will be discussing about how to control the settlement of approach slabs. Before talking about the approach slab settlements, we will be defining what is an approach slab, and then we'll see what are the different methods available in order to have a better control on the approach slab settlements. So what is an approach slab? An approach slab provides a transition between the roadway pavements and the bridge. This generally gives a filling between the bridge part and the road which is connecting towards to the bridges. Approach slab acts as an intermediate bridge to span the portion of the embankment directly behind the abutment or the back wall, which was excavated to construct the abutment or the back walls. For example, if you see the photographs, like on the left hand side, you can see the face, which is a structure, maybe it's a PUP or VUP or a bridge structure, showing one end of the structure, and on the right hand side the line which is being demarcated with a orange line shows that when the road is being constructed, it has been constructed up to the right orange line initially along with the main carriageway, and then this gap which is being demarcated with the orange line is being filled up after the completion of the bridge. So this is the portion which is actually a intermediate span which is getting filled up after the completion of the bridge. Then to construct the approach slab, you need to have a PCC on the gap between the bridge face, the back of abutment wall or the back wall, and the existing road. And then this will be covered with a RCC slab of say 300 millimeters thick, and maybe around 3 meters or 3.5 meters in length along the line of cross section of the road pavement. So this is the slab which is generally known as the approach slab, which is acting as an intermediate bridge or covering the span between the existing structure and the roadway which is meeting or approaching the structure for completing the project. How to control the settlement of approach slabs, or how to reduce the bump while approaching a bridge or a structural member during the travel on the road surface, because it is seen that irrespective of the fact whether it is a ordinary road or a district road or even if it is an expressway, the bumps while approaching the bridges are unavoidable. So this is generally creating a driver's discomfort, and especially for expressways where the speed of the vehicle is very high, to the tune of say 100 kilometers per hour or 120 kilometers per hour designated speed, and the actual speed is much higher than what is being denoted, the chances of accidents are high if you have a sudden bump while approaching the structures. So it is mandatory and required to understand the ways to control the settlement of approach slabs and reduce the humps or eliminate the humps close to approach slabs. So a number of procedures exist that will reduce the differential settlement at bridge abutments, assuming its causes is some sort of a soil compression of either the embankment fill or the foundation soils. Sometimes the erosion also plays a major role as far as the settlement of the approach slabs is concerned. Sometimes the weep holes provided on the walls of the abutments, which are left unattended with a geotextile membrane from the backside, allows the soil to move out of the weep holes, thereby reducing the thereby allowing the approach slabs to settle, because there will be an unforeseen voids being created between the bottom of the approach slab and the top of the soil within the approach slab areas. Methods to control the settlement of approach slabs are providing support to the approach slab at the free end, which has been discussed in part 1 of how to control the settlement of approach slabs, or by changing the construction sequence or pre-compression and lightweight materials filling the area behind the structures. Then the other methods which can be used is foundation soil consolidations, pre-campered approach systems, or approach fill stiffening. These three methods are discussed in detail in part 2 of how to control the approach slab settlements. In the current module, we will be discussing in detail the buried approach slab at 24 inches below the deck level or 610 millimeters below the slab top, and preformed grout holes, provision of preformed grout holes in order to control the settlement of the approach slabs. To start with, the buried approach slab at 610 millimeters, if you provide, the concept is being that the approach slabs are buried and is being provided at a depth of 610 millimeters from the top of the slab. The new design was further refined by Massachusetts Highway Department. The approach slab is placed at approximately 24 inches below the deck elevations, supporting the bituminous pavement and the underlying base materials. The positive drainage of subsurface water away from the back wall is achieved through a longitudinal slope, and a cushion will have an effect of controlling the bump at the end of the approach slabs. Because of this cushion, the impact of the wheel loads, which is due to the movement of the traffic, is less on the end of the approach slab. If you see the construction sequence, like on the left hand side, you can see a bridge or a PUP or a VUP is or a minor structure wall, which is shown in a vertical wall system, and on the right hand side of your screen you can see the existing road under construction, which is being done up to embankment top. Then you have the subgrade top, and thereafter you have the GSB top and WM top. This is the regular sequence of work which is generally in progress at any flexible pavement or rigid pavement construction sites. Now, the valley which is being formed because of the construction of the structure is being filled later on with the earthwork, mostly by layer by layers. up to the embankment top as shown in the dotted line. Then they fill these layers with the subgrade materials. Thereafter comes the GSB materials of 200 mm thick. Now, after completing the GSB material, the PCC for the approach slab is being laid, and then the approach slab is being constructed on the face of the bridge systems. Now, after completing the approach slab, then the WM layer is being laid on the balance area, which is as shown in the figure, and then the balance DBM layer is being done, and then over and above that the complete BC layer is being laid, so that the paving has to be uniform in the bridge areas. Now the idea is now, because the BC has a layer thickness of 50 mm only, so the cushion which is being provided on top of the approach slab is just 50 mm layer thickness. So the vehicles, when they are moving from the flexible pavement and approaching towards the bridge, the moment they cross the approach slab line, they are actually entering into a rigid pavement structure, because just below the BC layer you have the rigid layer of concrete, which is in the form of approach slab of 300 mm thick. Now the idea is, as the vehicle moves, because of the smaller section of these areas being filled up after the completion of the bridge, the possibility of pre-compression or the localized consolidation is high in these areas because of the lesser compactions. So as the vehicle moves and with the application of brakes and all, the chances of movement of soil in these locations are high, thereby making the approach slab to twist from the bridge locations. So the problem is, since the approach slabs are being designed in a cantilever portion, the free end was bound to get compressed, and these compressions are being supported by the movement of the soil beneath, which was not compacted properly, or maybe the soil was not 100% compacted in these areas. So this is how the hump is created, and which is being more predominant as the vehicles moves close to the bridge locations. Now the buried approach slab concept is a similar location, similar mode of construction, but what happens is the PCC is being done at 610 mm below the top of the deck slab. That means the approach slab is being casted at 300 millimeters below the top of the deck slab, and when you are doing the subgrade top and the GSB top, and over and above that you have a 250 mm thick WMM with 100 mm or 120 to 140 mm DBM, and thereafter you have the BC of 50 mm thick. That means the total height, which is say H1, is being divided into H1 into H2. That is, now in this particular case, approach slab is acting as a separation member between the two fill materials, which one is just below the approach slab and a layer of materials above the approach slab. Now this is also having an impact, like it provides a cushion on top of the approach slab, so that the impact of wheel on the cantilever portion of the approach slab is minimal, and even if the vehicle moves on top of the road, the movement of the soil because of the vehicle movement on top of the road is very minimal, which is not directly visible unless until there is an erosion from the side faces of the roads, and then the deflection in the bottom layers below the approach slab is not visible on top of the roads. Thereby the chances of creating a hump is being eliminated. So the advantages of buried approach slab, if you see, the fill height is reduced considerably by introducing a rigid pavement in between. The impact on the surface is minimal due to any compressions developed below the approach slab. The compression of the subbase and the base materials resting on the approach slab is negligible. the bump formation is almost eliminated while approaching the bridge position. So approach slabs placed at 610 millimeters below the deck level. If you see the photograph here, like if you have provided the approach slab at a location just above the haunch portion and below the top of the slab with a 300, and above approach slab if you are having the layer thickness of WMM and then a DBM, then the approach slab, the buried approach slab will have a cushion on top of the road, which will have a considerable impact on reducing the effect of bump when the vehicle approaches a bridge structure. So the other method to control the settlement of approach slab is preformed grout holes. It is a concept again, like if the designer presupposes that the settlement will be there in the approach slab because of the materials being used or because of the construction methodologies being adopted. That means the designer is already anticipating that there will be some settlement below the approach slab because of some consolidation issues of the foundation soils or the compression issues of the fill materials. Then the grout holes may be left in the pavement to facilitate the mud jacking operations. This option is currently the standard design of Missouri Department of Transportation MDOT approach system, usually called as MDOT approach system. The mud jacking is designed to fill the voids beneath the slab and will in some cases lift the approach slabs to the required position. And mud jacking is reasonably effective if the settlement is complete, and if the settlement is happens to be repetitive in nature, then the number of multiple times the mud jacking process needs to be implemented, which is sometimes time consuming and is an inconvenience created for the traffic also who are plying on that road. So the settlement of approach slabs on the sites, like if you can see a uniform settlement as shown in the photograph, then these can be pumped from the bottom by using a mud jacking or a grout material, and the slabs can be regained or revamped into its original position. Mud jacking to fill the gap in the approach slabs is generally effective when you know that the settlement is complete in all respect and there is no further settlement happens to be there, but the process should have the confinement from the sites also. Like in this photograph, if you have to do the mud jacking, then the sites needs to be confined so that whatever pumping is being in process, it should not get wasted from the free end. So to conclude, approach slabs are required to reduce the bump in the bridge approaches. The compaction process needs to be controlled in the approach areas. Activities like curbs, medians shall be completed with the completion of the approach slab. Compressions and consolidation effects of the soil beneath shall be accurately assessed and taken care of. Concept of a buried approach slab needs to be further elaborated, and trials should have been conducted in order to ensure that yes, the buried approach slab is going to be effective as far as the settlement of the approach slabs are concerned. Return walls shall be constructed instead of a wing wall, as the return walls generally creates a confinement from all the three sides, and the chances of erosion of soil due to the movement of the water will be minimum. Use of light materials or light fill materials in the approach slabs needs to be promoted, as the pre-compression or the consolidation of the fill materials will be minimum. Thank you.